We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system. Take a look, the striking infrared image.
The James Webb Space Telescope has once again forced humanity to rethink its place in the cosmos, this time by turning its powerful gaze toward Neptune, the distant ice giant long considered one of the most mysterious worlds in our solar system. And what it revealed was nothing short of astonishing, an impact event so violent, so unanticipated, that it shook the astronomical community to its core, reminding us that the universe is far from static, that even on the frozen edge of the solar system, chaos still rules. For centuries, Neptune has been the planet of shadows and speculation, glimpsed dimly through Earth's telescopes, seen in true detail only once during Voyager 2's fleeting flyby in 1989, which revealed a world of supersonic winds, monstrous storms, and an atmosphere painted in an unearthly shade of blue by methane gas. But since then it had been relegated to the periphery of human attention, its secrets hidden in the dark. Webb changed that in an instant. When its infrared instruments swept across the planet's faint disk, scientists expected to see the familiar patterns of methane absorption, shifting clouds, and perhaps the dim, delicate rings barely held together by Neptune's moons. But instead they detected a burst of thermal energy radiating from the planet's atmosphere, an unmistakable signal that something enormous had struck it with catastrophic force. Unlike Earth, where asteroid impacts leave craters as scars written across continents, Neptune's gaseous body swallows intruders whole, erasing the evidence beneath layers of hydrogen, helium, and ices. But Webb's spectral fingerprints told the tale. The sudden rise in temperature, the injection of exotic molecules, and the chaotic rippling of cloud patterns betrayed the destruction of an interloper, a wandering body likely torn from the Kuiper Belt, that vast reservoir of icy relics beyond Neptune's orbit where countless frozen objects linger in silence, remnants of the solar system's violent youth. This was no May pebble. Webb's data suggested something at least tens of kilometers across, perhaps even rivaling the mountain-sized comets that, in Earth's deep past, brought oceans and extinction alike. Drawn inward by Neptune's gravity, accelerated to unimaginable speed, it would implode into the planet's atmosphere with an energy release rivaling millions of nuclear bombs, compressing gases ahead of it until they ignited into a cascade of shockwaves that raced around the planet faster than sound. The object itself was annihilated, but in dying it left its fingerprints in Neptune's skies. Webb detected surges in carbon compounds, faint traces of ammonia, and spectral hints of unfamiliar ices, perhaps molecules never before catalogued, now adrift in the upper atmosphere, visible only because this great telescope was watching at the right moment. The discovery is more than a curiosity. It is a revolution in our understanding of planetary dynamics. Neptune, with its 17 Earth masses and supersonic winds, is not a passive observer on the outer edge but an active participant in the solar system's ongoing story, a gravitational giant whose invisible hand shapes the orbits of distant objects, herds comets, and occasionally dooms one to fiery destruction. Scientists had long speculated that Neptune's orbit hides mysteries. The strange clustering of trans-Neptunian objects has even led some to suspect the presence of a hidden Planet 9, and now, with direct evidence of a major collision, Neptune's role as cosmic gatekeeper is undeniable. But the implications ripple further. Impacts like this are thought to have seeded Earth with water and organics billions of years ago, and they remain a threat, as Chicxulub reminded us when it extinguished the dinosaurs 66 million years back. To see such a drama play out on Neptune today is to watch the same forces still at work, reshaping worlds in real time. And Webb's instruments revealed more than just chemistry. The heat signatures suggested disturbances spreading through Neptune's deep atmosphere, as if new storms had been born from the impact, storms that may churn for decades, their cloud tops visible even from billions of miles away, a weather system born of violence that might one day rival the great dark spot Voyager once recorded. The discovery forces us to reconsider Neptune not as a static ball of methane blue gas, but as a dynamic stage where the drama of creation and destruction continues unabated, a reminder that no corner of the solar system is truly safe from celestial chance. Humanity's reaction has been electric. Scientists are calling for dedicated missions to Neptune, arguing that a spacecraft arriving within decades could still study the lingering chemical aftermath. Planetary defense advocates warn that if such bodies can be perturbed into Neptune, they might also be perturbed toward Earth. Philosophers and poets see in the event a cosmic parable, a frozen wanderer's death echoing across the void to remind us of fragility and impermanence. And still the mysteries deepen, for Webb's data also revealed faint anomalies near Neptune's faint rings and moons, suggesting that fragments of the impactor may have survived in orbit, temporarily captured, creating debris that could form new ringlets, in time, spiral down to join the planet. Even Triton, Neptune's largest moon and a captured Kuiper belt object itself, may bear some subtle imprint of this cosmic collision, its tenuous nitrogen atmosphere perhaps stirred by the reverberations of Neptune's convulsions. To watch this unfold is to be reminded that our solar system is still alive, still dangerous, still capable of events we thought belonged only to the deep past. And in the end, Webb has not merely shown us Neptune's collision, it has shown us a mirror of our own world's fate. For just as Neptune swallowed an intruder in silence, so too does Earth await its next cosmic visitor, and the line between survival and annihilation may rest on whether we are watching at the right moment. Neptune's sudden burst of heat, its scar of alien chemistry, is not just a story of a distant planet. It is a warning written in methane and starlight that the universe is far from done with us, that collisions are not accidents of history but ongoing chapters in a book still being written across the skies, and that every world, no matter how remote, is a participant in the endless theater of creation and destruction. The collision witnessed by the James Webb Space Telescope on Neptune is more than a single moment of cosmic violence. It is a window into the deep and interconnected dynamics of the solar system, a chain of forces that span from the ice giant itself to the faintest whispers of the Oort cloud. Astronomers now understand that the object which met its end in Neptune's atmosphere may have been guided along its path by a variety of influences. Subtle resonances with Neptune's own gravity, the slow but inexorable perturbations of passing stars nudging ancient orbits, or chaotic scattering within the vast reservoir of icy bodies that encircles the solar system like a ghostly halo. The impact is therefore not an isolated planetary event, but part of the ongoing ballet of motion that keeps the solar system alive. What makes this all the more profound is the energy of the impact and what it may reveal about Neptune's interior. We often imagine ice giants as simple spheres of hydrogen, helium, and methane gas, but their depths are stranger than science fiction. Hidden beneath Neptune's serene blue clouds is a mantle of exotic matter, a seething mixture of water, ammonia, and methane under pressures so immense that water itself takes on unfamiliar forms, superionic ice that behaves like both liquid and crystal at once, lattices that can conduct electricity, layers where chemistry dissolves into physics. It is within these alien depths that Neptune's bizarre and tilted magnetic field is born. And a collision of the magnitude Webb observed could have disturbed these regions, stirring convection currents, driving unusual mixing, or even altering the flow of energy through the planet's interior. Since Neptune radiates more heat than it receives from the Sun, it is already a planetary enigma, a world fueled by internal mysteries we have never fully explained. And this impact may have acted like a natural probe, briefly altering the planet's thermal balance and magnetic heartbeat in ways that can be traced by careful observation of auroras, magnetic fluctuations, and thermal emissions in the years to come. But the implications do not stop with Neptune alone. Exoplanet science, one of the most rapidly advancing fields in astronomy, now gains an invaluable case study, because among the thousands of planets discovered orbiting other stars are many that resemble Neptune in mass and size, yet their atmospheres and histories remain mysterious. Astronomers studying such worlds have long struggled to account for anomalies in their spectra, unexpected chemical enrichments, irregular heat signatures, or atmospheric structures that seem inconsistent with steady processes. Now, with Webb's detection of an actual collision on Neptune, we can imagine how a hot Neptune orbiting a distant star might bear similar scars, its spectrum marked by the fingerprints of an impact long past, its appearance transformed not by steady evolution but by stochastic, violent events. Suddenly, those anomalies become interpretable, Not mysteries to be dismissed, but echoes of processes we now recognize from our own system. Webb's discovery is therefore a library card to a new archive of knowledge. The fingerprints of planetary collisions, sudden chemical enrichments, thermal pulses, and transient cloud formations that can now be used to interpret data from faraway worlds. The resonance of this event extends into speculation about the future of the outer solar system itself. Neptune's orbit is shared with countless icy wanderers, Trojans, centaurs, resonant bodies, and irregular moons, all stabilized or sculpted by its immense gravity. If one of these objects was sent hurtling inward to its destruction, what prevents others from following in cosmic time? Perhaps Neptune will experience not one but many collisions across eons, each a faint hammer strike reshaping its evolution. These cumulative impacts may explain some of its enduring mysteries: the unexpectedly fierce winds, the turbulent heat balance, or the enigmatic distribution of chemicals in its skies. On human timescales, these collisions are invisible, but across billions of years they may write the story of Neptune's personality. This realization carries a philosophical weight as well, for collisions remind us that the cosmos is a place where permanence is an illusion. Worlds may remain serene for millions of years, only to be reshaped in an instant by a wanderer from the dark. For humanity, safe for now on Earth, to witness such an event on Neptune is to be humbled and reminded of the universal indifference to stability. The forces that once battered our own planet into habitability and nearly extinguished life with mass extinctions are not relics of the past. They are ongoing processes still at play in the solar system, still writing stories on distant planets where few thought drama remained. As Neptune recovers, scientists will watch with keen interest for changes in its atmosphere. New storm systems born from injected heat, turbulence sustained for decades as energy rises and cools in great atmospheric cascades, rings subtly altered as debris darkens or brightens them, moons displaying faint orbital wobbles from gravitational aftershocks, auroras intensifying as the magnetosphere reconfigures itself under the stress. Each observation becomes a note in an unrepeatable experiment, one no laboratory could ever replicate, and Webb is now the instrument recording this grand symphony. The event strengthens the argument that Neptune deserves more than fleeting observation. It deserves a dedicated mission, an orbiter to study not only the collision's aftermath but also the mysteries that long predate it. If Webb, stationed nearly 1 million miles away at Lagrange Point 2, can see so much, what marvels could a probe in orbit reveal about Neptune's magnetic storms, its deep atmosphere, or its evolving moons? Already, planetary scientists speak of such a mission as inevitable, for Neptune has proven itself not a quiet backwater but a laboratory of planetary physics waiting to be explored. Yet beyond science, Neptune's collision resonates culturally and symbolically.